The way you read this is you start with the x. As x approaches infinity. Now what does that mean? As x approaches infinity. If you look at the graph, our x-axis is this right here. As x approaches infinity, we'd be moving this way, right? So as x approaches infinity, what is going on with the f of x? Now f of x is also the y, so we can write f of x right here, and it kind of makes it make a little bit more sense. And so as I'm moving along this x-axis right here, going to infinity, what is happening to the line? What's it doing?
The y value is getting closer to 0.
Yeah, it's getting closer and closer to 0. For the f of x, 0 is right there. And so this line is getting closer and closer to 0. So what's happening? F of x is approaching 0. Does that make sense?
Yes.
Okay, now let's look at it a different way. As x approaches negative infinity, so in this case we're going to the left now. So as we're going left on the x-axis, as x keeps getting smaller and smaller, what is f of x doing? In this case it is also approaching 0, but this time it's approaching 0 from the bottom. Okay, so as we keep going out and out, this is going up, and it's getting closer and closer to 0 right here. And so you would say that f of x is approaching 0. Now there's different ways to write this stuff, and so I mean, I took these pictures right out of your book, guys. I got these pictures from your book. I took screenshots of them so I could talk about them for a moment. X approaches infinity, x approaches negative infinity. We kind of already talked about that. Here we have as x approaches a from the positive side. That exponent with the plus sign in it is just meaning it's coming from the positive side. So, like your question, you said, what if we wanted to say as x approaches 0? Well, here you can't really do that. I mean, if you just say that, then you're saying as you're approaching 0 from both sides, what's happening to our graph? Well, we can't say that. We can't say what's happening because it's going up and it's going down at the same time. It's approaching positive infinity and negative infinity at the same time. But if we put a little plus sign right here, that just means we're approaching the 0 on the x-axis from the positive side. So as we're approaching 0 from the positive side, what's our graph doing? What's our graph? What's our f of x approaching? F of x is approaching infinity. Okay? The same thing with the negative, except now we're going from the left side. So if this said, as x approaches 0 from the left side, what's f of x doing? Okay, so coming from the left side, we'd be coming this way. Okay, so we're approaching it that way. And what's our graph doing as we get closer and closer to the 0 right here? It's going down. It's going down way down. It's like a song or something. It approaches negative infinity. Okay, so that's how you read those. That's what that little positive is. That's what that little negative is. Let's see what else we got here. Oh, okay, so here we have a common graph. Over here we were looking at the common graph of 1 over x. Okay, it's a rational common graph. Here's another one. This one is 1 over x squared. So this common graph is f of x equals 1 over x squared. Okay, how do we describe these different things? How do we describe the graph as x approaches infinity, negative infinity, 0 from the positive side, 0 from the negative side? Let's write it out. The first one, as x approaches positive infinity. No, just infinity. Yeah, it's positive infinity. What's f of x doing? Well, let's look at the graph. I'm approaching positive infinity right here. What's the graph doing? It's approaching 0. It's approaching the asymptote. Okay, so we know that there's an asymptote right here of y equals 0. It's approaching the asymptote. So we have f of x approaches 0. All right, let's try as x approaches negative infinity. As x approaches negative infinity, what is f of x approaching? So we're going this way now. What's f of x approaching if I go that way? This is f of x, guys, the y-axis. It's approaching 0 again. So we just say f of x approaches 0. Okay, now we have x approaching 0 from the positive side. What's f of x doing there? So we're going this way, We're approaching the 0 right there, and my graph is going way up, and that means it's approaching infinity there. It's not going to stop. So this approaches positive infinity. And finally, the last one, as x approaches 0 from the negative side, f of x approaches positive infinity again. Okay? Alright, now this just it's not a coincidence, but in this case, for this graph, there's a lot of common descriptions here, but they're not always like that. Here we have vertical asymptotes. So each of these have vertical asymptotes, and x equals a is your asymptote right here. And so this says as x approaches a from the positive side, so from the positive side, f of x is going to infinity. And then we also see something else different that you guys haven't seen before, right here. That's a limit. Limits we're going to look at a lot at the beginning of calculus, maybe even at the end of this semester. But what I want you guys to do right now is I want you guys to look at this one right here and see if you can explain it to one other person at your table exactly what it means. Like, what does this x and this arrow and this a with the negative on it means? And what does this part mean right here? Go. So these are vertical asymptotes, and you also have horizontal asymptotes. Okay, now horizontal asymptotes actually gives you opportunities to have, f of x approach something else besides infinity. So here, as x approaches infinity, so as we're going to the right, what's our line getting closer and closer to? It's getting closer and closer to b right here. So y equals b, and y equals b is our horizontal asymptote. So f of x is approaching b right there. Here, x is approaching infinity. This time it goes down, but it's still approaching b, the same horizontal asymptote. Now this is the weird one right here. Here we have a horizontal asymptote, but look at what the line does. It goes right through it, and then it comes back to the asymptote. So you can actually say that lines are attracted to asymptotes. So whenever you draw a graph, if it goes through the horizontal asymptote, it still comes back to it because the graph is attracted to asymptotes. All right.